Good morning, good afternoon, good evening to you, and I hope you're doing well. It is time for geometry. So I looked at your quizzes there, and some of you guys didn't do so well as I probably could have guessed. You guys need to ask me some more questions. I only got one question all day here. I'm sitting around the computers thinking, ooh, another person didn't do too well on their quiz. Why didn't they ask me any questions? Nothing. Okay, so please send me more questions. All right, I need to be able to help you. I only got one question. So, anyhow, your quiz scores, you're going to get 20% added to your grade, and that means that a lot of you guys are still not passing. So, what we're going to do today is go through your entire quiz. You can then redo the quiz. I think the questions should be exactly the same. All right. And you will get a better score unless you pay no attention to this video whatsoever. And then you will probably do just the same. But you should watch this video and it will help you greatly. If you don't watch this video, then that is just me wasting my time, and that does not make me happy. All right, so please don't waste my time. Make the most of this opportunity to do better and keep working hard. You should have tried maybe a little better on the original quiz, but maybe next time you won't be able to redo it, okay? You can't count on me giving you that opportunity to redo each and every quiz. You might just get a poor grade next time, and we're going to move on. All right, let's go over some stuff now. Okay, so this whole entire lesson is about similar triangles, okay? Now, you could have similar polygons, which have many sides, but a similar figure is basically something that has the same shape, but not necessarily the same size. Okay, and there's three ways to prove that triangles are similar. Remember this tilde, okay, that's the similar sign. Okay, so angle similarity, okay? And this is side angle side similarity, okay? This, if it doesn't have the tilde, then it's side angle side congruence, and that's how you could prove triangles are the same exact shape. But the tilde means that they are similar, and you could have side similarities. All right, and so in this similarity proof, the side pairs aren't equal, they have equal ratios. Okay, so if you reduce them, the ratios will be the same. So let's just, everybody hopefully can identify when you have two angles that are congruent. Okay, so they're similar, but side angle side and side might be a little bit more tricky. So let's look at a couple examples here that are relatively simple. Okay, so looking here, can you prove these two triangles congruent? What do you think? Well, I don't see any angles, and I'm missing a side. So since I don't see any angles, I can't use angle similarity. Since I'm missing a side, I can't do side similarity. All right. And since I don't have any angles, I can't do side angle side similarity. So right now, no, I cannot prove these triangles to be similar. However, if I put this angle here and make it a right angle, so we have a right angle, right triangles here, and another right triangle here, okay? I can't do angle, but I can do side angle side. Now I can't even draw that, so bear with me here 1 second. Try to make that look like a right angle. All right, there we go. Now, how do we know that this is side angle side similarity? Well, you see the angle is located in between the side pairs here. But these side pairs aren't enough. These side pairs have to have equal ratios. Okay, it says it right up above it, real big. So you want to pick the sides that go together, that are in the same positioning. Okay, so like this side goes with this side, and then reduce those ratios. So we could do 4 to 10. Or if you want to, you could do 10 to 4. Okay, 4 to 10 reduced is 2 to 5. Okay, so the 1 ratio is 2 to 5. And look, the bottom ratio is also 2 to 5. And so, yes, you could do side angle side similarity to prove these two triangles are similar now, okay, because they both have the ratio 2 to 5. Now, you could also do 5 to 2, okay? You just start with the big one and put it over the small one. You just have to be consistent and go in the same order for both triangles. All right, looking at this one, once again, you don't have enough information, okay? You don't have an angle, all right? So you need to know something else. Okay, so let's pretend like in this time we don't know the sides. We need to know one more pair of sides here. So let's call this side 5. Okay, and this side we're going to call 10. Now we have to prove that it is side-side-side similarity. And so to do that, okay, what it might be good to do is, redraw this figure so that it's oriented the same way as this one, okay? The cool thing about this is I could just take this and flip it like that, all right? And then move this here. So the 10 was there, and it got kind of messed up. The 6 was there, and the 8 was there when I flipped it. All right, so anyways, you want to make sure to match up the smallest side with the smallest side, the largest side with the largest side, and the medium one with the medium one. All right, so let's see if these ratios are all the same. All right, so we have 3 to 6 reduces to 1 to half. 4 to 8 also reduces to 1 half. And 5 to 10 reduces to 1 half. And so, yes, these ratios are all the same between the sides, and we have side-side-side similarity. Okay, now let's look at your quiz and be precise on it here a little bit more here. Okay, so looking at these figures, we know they are similar already, okay? So, since they're similar already, the angles that are in the same position are congruent, okay? So what you don't want to do is say that angle B is equal to angle D, because these are not in the same position, okay? But you could do 4x minus 6 equals 42, because angle A and angle D are in the same position. Or you could do 7x plus 10 equals 94, because those are in the same position, all right? And if you solve each one of these equations, you should get the same answer. So let's just go ahead and solve the first one. We're going to add 8 to both sides. We'll get 48. X is equal to 12. Now to prove it, subtract 10. 7x equals 84. And guess what? X is equal to 12. 84 divided by 7 is 12. So that's it. You just had to find X. All right. On this one, what do you need to know to prove the triangles are similar? All right. So look, they're talking about all side ratios here. So, you can't do angle, okay, with these choices here. It looks like you're going to be doing side, angle, side, okay, to prove that they are congruent. Because you have a side, you have an angle, and we need to know this other side. So we need to know this side and this side have the same ratio as the other two sides, okay? So if we go from big triangle to small triangle, we would compare KL, okay? Now you want to think about, see these triangles, this one is a turned version of this triangle. So the 56 goes with the 7, okay? So you're comparing KL to YZ. So you want to reduce 56 over 7. Whoops, let me go back here. It's a little tricky here. Easier just to write, but maybe I'll just get the pen and write. Why not? Yeah, we'll try that. So 56 over 7, that reduces to, and I apologize for sloppiness, but this is the best I can do here. That reduces to 8. So the ratio from big to small is 8. All right. Now let's see which ratios use those sides. JK, okay, YX. That would give you side-side angle. You have to use the sides that make it so that the angle is between the two sides here. See, one side, other side, angle. You can't use this other side over here because that is side-side angle, and you have to do side, angle, side, or nothing else. Okay, you can do side, 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 but that's not, you are only given one extra piece of information, not two. So you can't do side, side, side in this case. All right. So this is a bunch of garbage. Don't use that one. JL compared to ZX is 1 to 8. All right. We have to get from big to small for it to be 8 to 1. So this ratio is actually backwards. So that one's not it. All right. KL, okay, to YZ is 8. We already know that, okay? That's the one we just figured out, so you don't need to know that one. So this is the one that we need to know right here. Okay, that's 8. Side angle side would prove that if that particular ratio is 8. Okay? All right. Here is an interesting one. You're given 2 triangles. What must be true? All right, so let's talk about this one real quick. So the first thing you should do is draw out those triangles. So let me attempt to draw out those triangles really quick here, and then you could try to go along with me here. All right, now when you're drawing out the triangles and labeling them, you want to go in the same order. So like F, G, H. So I went top left to bottom. So when you're doing this one, you have to go top left to bottom too for the first 2. L, M, N. Okay, so seeing this should help you. If you didn't draw this one out, shame on you. Okay, you need, I mean, every time we have this without a picture, I tell you to draw it out. So you should get used to that by now, okay? Sorry to be mean, but, you know, come on, guys. Get with it. FG, the ratio FG to LM, okay, so they are similar. So what must be true? So there's 2 things that must be true. The angles in the same position are all the same. Okay, the angles are congruent, and the sides, they're not congruent. They are proportional. Okay, so what must be true if it is similar? All angles are congruent that are in the same position, and the side ratios of corresponding sides are equal. Okay, so let's actually see this here. Okay, so FG to LM, okay, is equal to FH to LN. You have to check all the things that are true. And yes, these are sides that would match up. And so those ratios would have to be true. Letter B, FH is similar to LN. This one's a little tricky. In similar figures, okay, the parts themselves are not similar. Okay, parts can't be similar. Parts can be congruent. Parts cannot be similar. So that doesn't work. And angles are congruent. The ratios of the angles, who knows anything about? Okay, so the ratios of the angles, that's a bunch of garbage. Okay, that's just trying to make you think crazy thoughts. GH is congruent to MN. No, the sides are not congruent. The sides are proportional. Sides are proportional. Okay, not congruent. So that's also not true. Okay, and the last one, measure of angle H is congruent to measure of angle N. Remember, that is true because all angles are congruent that are in the same position. So look, H and N, they're in the same position, so that is true. All right, let's go on to the next one here. Okay, now this is a little bit of a tricky one, so I'm going to stop the video and film part 2 because I'm getting close to my 15-minute mark here, so I don't want to get cut off in the middle of the video. All right, so catch you in a second.